Hi, this is Joris Peels with the 3D Printing News Unpeeled, thanks to 3dprint.com. And today we're doing a news roundup of the most relevant 3D printing stories of the day. For today, we've got six stories for you. The first one is the Pylo Super Smart Helmet. This is a prototype. It's an article that was on Design Boom. Uh, it's a prototype, we don't know if this is going to be an actual end of an actual product, and if it's going to be on the market. But it's the a helmet called the Pylo, is made by N Frontier, and it's got a 3D printed kind of liner in it, and that protects your head. As a yet another example of a bike helmet. There's a bike helmet that's being used. NFL helmets and other helmets are being used as well. 3D printed components on it. So this is an area of focus for me. I think that's going to become a much larger application for us going forward. And the idea, of course, is we can make custom textures, we can make custom shapes, we could customize it to your head. But the most important thing so far is that we can optimize a shape that is really good at absorbing very fast impacts, very sharp, fast impacts, and at the same time, we can have that structure absorb very slow, heavy impacts as well in the same kind of shape. And that's very difficult to do, or impossible to do, with like other liners and of plastic and polymer materials, or other liners of made out of foams and other materials. We expect to continue to see these kind of things develop as time goes on. I'm very bullish on 3D printed helmets generally, and sports equipment as well. So this kind of thing really interests me. What the other things this helmet has make me feel a bit more skeptical about it ever coming to market, because it's got LiDAR radar sensors on it. And good luck trying to buy those, by the way. 3D immersive sound, LED light indicators, a face shield airbag, a smart 360-degree surround safety system, and a 3D knitted inlay. So I'm not sure about all those features in one helmet. I love the 3D knitting inlay. I've been noticing lately a lot more people have understanding the 3D knitting technology as a complement to 3D printing. That's always going to catch my attention. News item number 5 is Spectroplast, 3D printer on the market. Came to us via All3DP. Spectroplast is an innovative Swiss company that's is commercializing some silicon additive manufacturing technology to make silicon 3D printed parts that can be used for medical applications, but it can also be used in a lot of industrial applications as well. Traditionally, silicon has been a very difficult material to 3D print. We've sucked actually at any kind of flexible, long-term, durable, flexible material. So this is a good development. They're finding lots of application for it. I'm very enthusiastic about Spectroplast as a company and how they do business and their technology. So this is always going to catch my attention because of that. And just silicon, I think, should always be something that we now should understand that we have in our arsenal. And so Spectroplast up to now is functioning as a service, and now they're going to be making available, widely available, the printer to certain select customers. I like this because we've seen companies that have started as a 3D printing service only with the express purpose of trying to develop their own printers later on. And Spectroplast is now saying, look, we're going to stay a 3D printing service for most of our customers, but certain people need quick turnaround time, need to produce in a certain area, something like that. And these guys can still buy a printer. So it's giving your customer options. They'll have less control, obviously. The customer may be able to reverse engineer the process, for example, partially. But at the same time, you're catering to probably what is like some very high volume customers, and giving them what you want and inhibiting competition. So I think the idea of doing both is maybe feels a bit kind of like it wouldn't make sense to a lot of people, but I think it's an interesting way to do business. So that's why that's here. Number 4 is approval for 3D printing buildings on Montana, or actually, well, approval for a particular type of 3D printed wall in Montana, actually. This comes to us from TCT. These are some state building code regulators in Montana that are the first in the states to approve 3D printing for a CMU wall. CMU they're called cinder blocks or breeze blocks. These are concrete kind of blocks you get everywhere. So now instead of those walls, you can use 3D printing. Thanks to Tim Stark, who's a contractor in Billings in Montana, and he's used data and the process of APIS Core or APIS Core. No one's really sure yet about how to pronounce that, but only those guys. These were tested by an independent lab in Boston and also the Civil Environmental Engineering School of the University of Connecticut. And the specification was published by the National Fire Protection Association. Apis Core says that its constructions can be 30% cheaper than conventional constructions. And yeah, this is just a good step. We're really very skeptical around the 3D.com about 3D printing construction because a lot of people have lied to us. A lot of people have told us essentially outright falsehoods or overly optimistic things. And so, to us, any kind of approval or any kind of regulatory approval that says, hey, we're going to get an architect to put her signature down, we're going to put our signature down, and we're going to actually build something and get sued if it collapses and stuff like that. That's a really a big step. And any kind of like thing like that is something we're going to welcome and look towards. The number three bit of news is that American Airlines has put down a deposit to acquire 15 Overture jets made by Boom Supersonic. Boom Supersonic is a company that is going to, essentially make in 2025, they hope to make a supersonic passenger jet that can take about 60 to 80 passengers to Mach 1.7. There's very little in terms of new entrants in commercial aviation. It's a very difficult place to get things approved, very difficult place to innovate. We see a relatively lot of players in military aviation and kind of business aviation, general aviation, making smaller aircraft or business aircraft, VIP aircraft. But commercial aviation, we've actually seen like kind of a shakedown and kind of less players maybe even coming about the last couple of years. It's a very difficult place to make money. And to see Boom Supersonic try to penetrate that market, it's very ambitious on their part. And they're not just making a short regional jet, which in and of itself is going to be really difficult, right? But they're making something that's really going to change the way that certain people travel. Like in our article on 3dprint.com, we got this news from, the number that Boom Supersonic said for certain flights is that it's going to cost like $5,000 for a flight or something. Now, it's very difficult to make money with, in airlines generally, but also business class flights are also these kind of shorter flights. And of course, previous supersonic efforts did not really work out that well economically, and also because the sonic boom would disturb people living closer to the airport or destination. Here's to Boom Supersonic pulling this off. The company has some help from Northrop Grumman, Collins Aerospace, Safran, and Eaton. Northrop actually wants to use the same aircraft to make militarized special mission versions of this aircraft. It's got a number of partners as well around it. So, they seem to be doing everything right. Now, with this order, this is actually like 15 these aircraft. This is a non-refundable deposit by American Airlines. And it has an option to buy 40 more. So American Airlines really hopes that this is going to be something to really help their offering. So it's a big move by them. It's a nice to see an airline like Transworld Airlines did with the 747. It's nice to see an airline really get involved and really bring innovation to air travel. Now, why is this relevant for us? There's at least 21 3D printed parts, probably a lot more on the XB1, which is kind of like a scaled down version of the Overture jet. These include variable bypass valves, engine fuselage manifolds, NACA ducts, and ACA ducts. It's like an air inlet duct. And these come off of the Sapphire printer from Velo. There's other components on the aircraft that are made on by Stratasys Systems. So, there have been, of course, 3D printed parts on Boeing commercial aircraft and a lot of other aircraft for years now. But we're seeing a new level of criticality in these components, a new level of kind of like these important components doing more important things than just like AEC ducting. And that's a good move. It's a good for all of us. I think also, this whole Boom Supersonic is still to this very day a very risky kind of adventure of an aircraft company at the moment. To penetrate such a market with such a revolutionary aircraft is a very, very difficult thing to do. And it's going to require a lot of money, a lot of work, and a lot of really good engineering. And for both Stratasys and Velo3D to get involved in a very early stage, it took, there was some risk for them as well. They could have just talked to these guys, did a lot of work on qualifying these parts, making these parts, and then the company could go bust. It still could happen, by the way. And I think this is a real lesson for other people in saying, yes, it's good to talk to Lockheed and Boeing and all these guys, but there are also startups out there that could really, be more receptive to new ideas and really bring these to market maybe much faster than some of the bigger players. So big move all around in this, and it would be really exciting to see these guys revolutionize air travel. The second news is it's a paper, right? And it has 3D printing has positive effects on global trade. This comes from the Times of San Diego. It's a paper written by Carolyn Freund. She's the economist and dean of the School of Global Policy and Strategy at the University of California, San Diego. What she did, what Professor Freund did, was it's actually really interesting. It's really very counterintuitive to a lot of people's thinking. It's very counter to what most, if not all, people in 3D printing think. So she looked specifically on hearing aids, but also I think about 25 other 3D printed goods, and looked at their effects on global trade. And what she's saying is that in the hearing aid example, right, there was a doubling or near doubling of produced exports after 5 years, and the technology was the main cause of the rise of these exports. She goes on to say that technology is a boon, not a curse to trade. The country's exports of hearing aids increased more than trade in other similar goods following the adoption of 3D printing by manufacturers there. The new production technology in combination with trade means that consumers around the world suffering hearing loss are benefiting from better, often cheaper hearing aids. Another quote is, policymakers often view 3D printing as a means to shorten supply chains, when in fact it is more likely to enhance trade and reshape supply chains. Now, the paper actually goes on to say, that some of this is a concentration of investment, and some of it is due to the fact that hearing aids are quite small, quite high value, and they're therefore quite easy to ship around. What I think is also very important is the types of companies that were involved in the early days of 3D printing were very top-down, very control-oriented businesses. And they're the kind of businesses that will want to remain in control of what they're doing. What is the important effect for us to realize is that we have the tendency to all talk about decentralized manufacturing. And in some cases, it makes sense. But in a lot of cases, either culturally from the business or economically, it may not make any sense whatsoever to have any decentralized manufacturing. And if we look at a lot of these hearing aid producers, they operate from very few centers. Even some of them have a worldwide presence of hundreds of countries, but they have very few, or even sometimes one a main production location. So this is something for us to take into account and really think about, because automatically people always assume oh yeah, we're going to do decentralized manufacturing. Well, in a lot of machines, especially really high level powder bed fusion stuff, filling the machine is so expensive, and the machine utilization is so important that it may never ever make any sense for you to do decentralized manufacturing. If we look at investments in post processing, these could also mean that centralized or very few manufacturing sites could still make a lot of sense going forward. So I'm glad to see this kind of counterintuitive stuff kind of shake us up and think, well, wait a minute, we need to think a little bit differently about this. The number one story about 3D printing today is also about hearing aids. This is a story we got from the New York Times. We wrote an article about it on 3dprint.com as well. And it's FDA clears path for hearing aids to be sold over the counter in the United States of America. Now, this is huge news. Hearing aids of in-the-ear hearing aids, which are the ones customized and go in your ear and fit directly to your hearing canal, your ear channel, whatever. Those are predominantly, if not nearly all of them, are 3D printed. These ITE hearing aids are 3D printed using either kind of per factory systems or SIGA systems, maybe larger 3D systems as well. And these dominate that market. And we've comfortably been doing this in the hand of a clutch of companies that deploy this technology very early and disposed of anyone competing with them essentially in that segment. Now, right now, with this article, they will be possible for people with mild or middling hearing loss to buy hearing aids over the counter, like at a Walgreens or something, or to buy it online. This is supposed to reduce the cost of these hearing aids and make them wider available. And also, it puts audiologists kind of out of the game and kind of bypasses the audiologist. Um, and you don't need a prescription for it, and that could really revolutionize this market. Now, on the one hand, what it could mean is that 3D printing is deployed beyond ITE to do, for example, localized production or to do really low cost production. What could happen is that people figure out ways to do ITE scans or ITE kind of impressions in a Walgreens or at home, right? Maybe people want to be sent these wax parts to their house. They will then send them back to the company, and the company then sends them a customized hearing aid without any involvement by existing companies, existing audiologists, existing retailers. So that could really use a lot of volume. And we can see with that same kind of a business, you could also make available customized headphones for people, for example. So that could be a huge on the 3D printed advantage side, right? What could also happen is that these lower costs would mean that people will turn to like lower cost systems like clusters of Formlab systems, for example. Or maybe people could say, you know what, I'm going to go to kind of like a desktop, much cheaper 3D printer, like a Frozen or whatever, and 3D print and do a whole cluster of them. Maybe some of them will fail, but I'll have 100 of them and I only need 25, right? And then I'll use really low cost resins to make these things much more available. Now, what could also happen again is, of course, that somebody decides that the volume is so great, they decide to make like 250 molds, right? Which will fit like 80% of the people. For example, I don't know if this is true, but if it fit 80% of the people well, and then of course it'll wipe out this in the ear hearing aid market that is now exclusively 3D printed almost. So, to me, this is a big, big, big thing. So, because we really won in the ear hearing aids for now, and now we could then dominate hearing aid production generally through this move, or we could get wiped out. So this to me is it will have far-reaching effects on the resin market, photopolymers, on the development of the VAT polymerization market in particular, but also on just 3D printers. Will all of a sudden people now, I could set up shop tomorrow and make hearing aids. Right? Are a lot of people going to do this? Are there a lot of people going to offer low-cost hearing aids, like hearing aids while you wait? Is that going to be a business? This all could happen now. So I'm very, very excited by this, and I think you should be too. And also, well, excited, but also it's like it could be a big risk for us. So yeah, I hope you enjoyed today. I hope this is useful for you, and thank you for listening. Tell all your friends, and have a great day.